Okay, if we consider a very first chapter from our course outline, so the very first chapter is related to the physical quantities and units, right?
Yeah.
Physical quantities and units. And you know that this in IGCSE this section is already very much reduced because vernier screw gauge was excluded. So
Yeah.
did not ask about that in the latest syllabus. So we know that this chapter is very much the same. In this, we need to know about the quantities, the SI unit, like the volume. What is the SI unit for volume, for the time, for the speed, for the electric current. So these are some basic concepts that is related into the very start of this chapter. So I don't think that you need to learn and revise that again because we already studied many quantities in 5 chapters. So we already have concept related to that, right? And do you have concept of
All right.
base quantities and dry?
Yes, I do.
Okay, so there are
Yeah.
7 quantities, right?
Yeah, they have there's a normal one, then there's centi, there's milli, there's nano, there's
No, no,
giga.
those
Um
are prefixes. We are talking about base
oh, okay, yeah.
mass
Yeah,
length.
yeah, okay.
Yes,
Yes. Okay, yeah. So weight, mass, length, time, uh electricity,
yes.
right? And
Electricity
there's one more.
density, temperature, amount of substance, right?
Yeah.
So these are the base quantities. So you already know about that. So we don't need to discuss again that one. So we have a concept of base quantities. Then all the quantities different from the base one are known as the drive quantities.
Yeah.
So there is a concept of base quantity, drive quantity in this
The
chapter.
direct quantities include like acceleration, speed,
Yes.
and all of those.
Those are combined from the base quantities, right?
Yeah.
Okay. And then we have a concept of scalar and vector. That is also very basic, right?
Yep. Scalar is basically only magnitude, and vector is magnitude with direction.
Yes. And now next one is the concept of combining the vector in the diagram form, that how to combine them. If you remember that tip to tail rule or
Yeah.
head to tail rule, right? So you
Tail,
also know
head,
about
head to tail, tail
yes,
to head.
yes,
And then you make the triangle, and if you don't want to do that, then you can make the parallelogram.
yes.
Parallelogram.
So
Yeah.
that is the concept, okay? And then we
Okay.
are there is a concept of random and systematic error. So basically there is a we can say that there are type of errors. The one is known as the random error. So basically when we are performing experiment in laboratories, so we know that the all calculated values and the all measured values are not completely exactly equal to the original values, because there are some error, there are some factors that will change the result or that will affect the result, right? So basically if we talk about the random error, so we can say that it cause unpredictable fluctuations, because that's why it is known as random error, because it is unpredictable, right? It may be anything, right? So unpredictable fluctuation in an instrument's reading. So basically, this is due to unpredictable fluctuation or unpredictable change in the values or the readings that we are making from any instrument. And due to this, there will be a result of uncontrollable factors such as environmental conditions. Right? Let's suppose if temperature is suddenly increases, let's suppose we are working in AC room and AC stops to work, so the temperature will starts to increase, right? So due to that change in temperature or increase in temperature, maybe your experiment got affected, right? So due to this, there may be some errors or there may be some changes in the readings. So these readings or these concept of error is related to the random error, right?
Right.
And we know that due to this random error, there will be effect on the precision of the measurement, right? That is due to that your readings or your range of your final result or range of your final answer will be wider as compared to the original one, or it is about, we can say that it will be more wider as compared to the mean value of the readings that you taken from the experiment, right? So basically it affects the precision.
Okay.
And next type is the systematic error. And by name you can easily identify that it is due to some system fault or due to some failure in the system during the measurement. Let's suppose if we are using instrument or if we are using like a wire in any connections, right? Just like if we take the example of the electrical circuit and we are using wires, and on that wires there is a rust on the wires, right? So basically we are using a faulty instruments, right? And due to that fault there will be systematic error, right? Because that will increase the resistance, that will change the value of electric current, because our instrument is not completely uh, pure and very clean as compared to the original condition or the original situation of the experiment. So this is due to the faulty instrument use or we are using in the experiment. Like if we are working with electricity, so we are using old cells, old batteries, so that was already half drained. So that will also change the value of electric current. We are supposing that these batteries or cells are the new one, but those are the old one. So that automatically decrease the accuracy of your results, right? So it arises from the use of faulty instruments used or from flaws in the experimental method. Yes, this is one more important thing that we are not considering, or we are not following the proper procedure. So that will also affect your readings, right?
Yeah.
That's why we started from the last chapters, because the initial chapters are like slightly boring as compared to the last one. And one more thing, that in random error we discussed that it affect the precision, and this will affect the accuracy of overall readings, right? So this is the concept of, or this is the basic difference between random error and systematic error, right? And there is one more concept related to the error, because whenever you start to perform the practical, so always we check for the zero error. Just like if we are using a ruler, let's suppose, so we know that ruler starts from the first division that mark zero, right? But let's suppose if your ruler is slightly broken from the initial point, or it is not correctly marked zero over there, and we just starts to take reading, so our reference point is already a faulty, and we don't just take the zero error, because that counts to be a zero error, because one division is not there, so our total division is already disturbed. So we need to take the reference that when we are measuring the values, let's suppose we got the reading 1 centimeter and one division is missing, so actually we are getting 0.9 centimeter, right? Because one division is missing. So that's why we need to take care of that one also. If we are using that instrument, so we need to record that value, that this is the zero error in the instrument, right?
Okay.
So the next concept is related to the zero error, and we can say that this is also a type of systematic error. Which actually occurs when an instrument gives a reading.
Assalamu alaikum.
Yes, walaikum assalam. When the true reading is zero. Screen is visible now.
It's still loading.
Okay, wait. Now it is. So basically, we need to check our instrument, that our instrument is perfectly, or the true value is equals to the zero. If that was not, or that reading is not equal to zero, or if a scale or any instrument is not starting from the base value, or that mostly we start from the zero, every scale or whatever instrument we are using. So there will always a value of zero, because that is our reference point, that is our origin. So we need to check that instrument has a true value of zero, or we are starting from the original value of zero. If it is not starting from zero, so that is known as zero error, right? So don't worry about that. We need to just record that reading, that there will be error of this value or this quantity. And after finalizing our values, finalizing our result, we need to add or subtract that value from the final result, right? So this is the concept of zero error. Okay. Just like the example of the ruler, if we take the example of a ruler, if the divisions are marked like this, if we consider the example of a ruler, so on ruler the divisions are marked like this, let's suppose.
I understand what it means by zero error. Yeah, it's very common.
Because sometimes student got confused in zero error. They are thinking that that must be related to some zero value, zero quantity. So actually it depends upon the instrument, right? Because vernier caliper screw gauge is no more included. Otherwise there is a very good example or related to vernier caliper screw gauge, but we are not using that one, so there is no need of that. Okay. So this is the concept
Okay.
related to the error. This is the new one, the new topic as compared to the previous syllabus. And now the very most important topic from this chapter, which is related to uncertainty, right?
Yep.
So this topic is very much important, because this concept is completely included in your A to P5 also. That is just like the alternate to practical paper. So there is one complete question and there are values in the table, and you need to complete that table with the uncertainties values. So this topic is very much important. And in A to P4 or the theory questions, they will also ask that to correct the value or to correct your answer by using the uncertainty in the answers, right? So basically, this topic is very much important. And what actually we need to discuss in this uncertainty concept. So basically, whenever, as we already discussed, when we ever calculate any value, let's suppose if we are calculating value of G in the laboratory, so we know that we will not get the exact 9.8 or 10 Newton per kg value in the laboratory, right? There will always a difference in the actual reading and the calculated reading, right? So the difference between the actual reading taken and the true value or the calculated reading, we can say that. So the difference between both values will give you the concept of uncertainty, right? Because we discuss about the concept of error. So those are the causes that why there is a difference in the readings. But if we are getting those errors, so what next we do? So next step is to follow the uncertainty process, right? To compare the difference, to find out the difference, that what is the difference between the actual value and the true value, right?
Yeah.
So we can say that the difference between the actual value or actual reading and the true value. Now actual reading taken means the calculated one, right? And true value is the original value, just like we take the example of 9.81 or 10 Newton per kg. So that is the concept. And there are three types of uncertainties. So we need to discuss about those three uncertainties concept. The first one is absolute uncertainty. So the first one is absolute. And in absolute uncertainty, what we need to discuss, we need to discuss when uncertainty is given as a fixed quantity. We will also talk about the example that will give you the clear concept that what is the difference between these types of uncertainties and how we are going to discuss about these differences. And the next type is known as fractional uncertainty. So basically in fractional uncertainty, what we need to do, we by the name we can easily identify that your uncertainty will be in the fractional form, right? Because first one is the absolute. So in absolute we are going to add or subtract the values like this, because those are the fixed values. But in the fractional we are going to take the fraction of the values, right?
Yeah.
So in short, if we talk about the absolute, so in absolute we are going to work with the addition operator and the subtraction operator, right? And if we are talking about the fractional one, so your uncertainties will be in the fractional form. Okay, so fraction means we are going to use multiplication and division methods, right? And the third type is the percentage uncertainty. This type of uncertainty is most going to be used in our questions and in A to P5 also, because in this we are going to calculate the percentage error. In simple words we can say that. So in percentage uncertainties, given as the percentage of the measurement. And you already know about the formula of percentage, just like the efficiency.
Yeah.
We are going to divide the actual reading by the true value or the standard value multiplied by the 100%. So we will get the uncertainty, right?
Can I rejoin the meeting? I have to take a call.
Okay. Different types of uncertainty. Let's suppose if we consider the example for the absolute one. So we are having one example like this. Let's suppose if we are having one quantity, let's suppose A, 2.0 plus minus 0.2. So basically this plus minus is the uncertainty, right? Because we can say that there is a range of value that it might be 1.8 if we subtract 0.2, right? And it might be 2.2. So there is a range between 1.8 and 2.2. Okay. So that is uncertainty, right?
Yeah.
And the second value is, and in question they are asking, find the quantity C, which is actually equals to A plus B, right? So how
So
you are
the
going to find?
uncertainty, the C is 5 plus minus 0.5.
Yes. So you just simply add the actual values plus the uncertainties values, right? So your answer is right, 5.0 plus minus 0.5. Okay, so this is the very common example because that is absolute. So we just need to add the values, or if we talk about the subtraction, right? So let's suppose if we take again the same values A and B, right? And they are asking to subtract the value. So what do you think that how to find out the final answer then?
If C is equal to A minus B or
Yes,
B
if we
minus A,
A minus
it's
B.
gonna be like if it's A minus B, then you're gonna get minus 1 plus
Okay.
minus 0 point negative 0.1.
Okay. Now this is the very important point that we need to discuss, because in addition it is very normal, right? Because we are talking about the errors, basically uncertainties are due to the errors, right? If we take the reading from faulty instruments, so we just take it might be like close to this one or that one. So we just, when we are thinking like that, so that is actually uncertainty because of the error in the instrument, right? So always remember one thing: errors cannot be subtracted, right? So the most very important thing is in this concept is that we are not able to subtract the errors, because if there is an error in your instrument, so it will always there throughout the experiment, right? Even if you are performing experiment with the zero error, right? But still there is an error in your instrument, right? Got the concept? So let's suppose you start the experiment, right?
Okay.
And you start without taking zero error, right? You just start the experiment without checking zero error. So there is one error at the start of your experiment, right? And then you are performing the experiment and you take 5 times reading, right, of any experiment. So first error is you didn't note the zero error in the experiment. And what will be the next? You record first value without zero error, second value without zero error, third, fourth, fifth. So your errors are now adding, right? You know that when someone makes fault, or we can say that any remaining task like in the previous day, so we are not able to subtract that one, we are just adding them. Or if we are talking about our lackness or our weakness, or when we are not working on that, so our weakness will day by day increasing, right? It will not overcome by any good deed or any other habit. It is still, it was still there. So just like the same, you are, if you once take the error in your experiment, so it will continuously adding into your experiment, right? Because you are performing reading one by one, and your errors are also including one by one. So errors can never be subtracted, right? So remember one thing.
Or
So now it is typical to find out, because we know that we are not able to subtract. So this is now no more simple. So what we need to do? we just take the value. This purpose we need to do, we are going to take the percentage, right? And how to take the percentage? Let's suppose we are going to calculate C. So actually what we are going to do, we are going to find out the percentage error in C, that will be equal to percentage error of B divided by. So we never subtract the errors, we need to find with the in the form of fraction with percentage, right?
Right.
Okay, so we are not going to multiply the errors, because errors are going to be added one by one. It will not like this. If you just perform any experiment, or there will be error in your experiment, and you just going to multiply and divide the errors, we are actually finding the percentage of the error in that value, right?
Yeah.
So basically we are going to perform like this if we are taking the division of that experiment, or we can also say that, let's suppose if we are adding them, so we can say that we are actually adding the percentage error of both quantities. Okay, this is A. Okay, so either we take the fraction form, because that is the type of uncertainty that is already over there, and the third one is uncertainty. So basically if they used to ask about subtraction, so it cannot be subtracted. Either we are going to find the percentage in fraction form, or otherwise we just find the individual percentage of their errors and then combine the percentage of their error to find out the final one, right? So let's suppose if we
Yep.
take the example, so we are going to find the percentage error in B, the first one. So percentage of B is very simple. We know there is an error of zero point 0.3. So zero point 0.3 will be divided by the original value, that is 3.0, multiply by 100, right? So you will get answer 10. Okay.
Okay.
So it means there will be 10% error in your actual reading, right?
Even in A, there's gonna be a
Yes.
10%
It
error.
also be same like for the A. So again, 10% error in the value of A also, right? Now, finally, what we need to do, we just find the values. If they are asking in fraction, so we use the formula of fraction. Otherwise, if they are asking about the subtraction or like that thing, so what we need to do, we just need to find the percentage first and then add their percentage, right? So that will give you the concept. Because in normal addition, we just combine the values. Your answer is completely different, right? So your
Yeah.
final step will be the percentage error in C is equals to percentage error in A plus percentage error in B. We know that we got 10%, 10%. So in the answer of C, we are going to have 20% error, right? Because you know errors are going to be added one by one. Okay.
Oh,
So basically, when we are calculating the percentage, so percentage in error means that there is some amount or any amount which we are writing in the question, that this amount of error is in the actual value, right? So now for the final value, what we need to do, we know that C is equals to what?
C is equal to 5.0 plus minus 0.5.
Okay. Yes, one more thing, because we know that we are not going to subtract the value of C, because actually question is C or B minus A or A minus B. So you just, if you know the concept of the log, if something is subtracting, so we just convert into the division, right? So we need to also find out the changes in the original value of c. So c will
Okay.
be actually equals to,
I want to find out if it's 4.5 or if it's like 5.5.
yes. So first we need to find this value, 1.5.
1.5.
Yes, and finally what we need to do, we know that the error is 20%. So the total change is zero point 0.3, and your final answer is, this is your final answer, right?